Okay, so after you have learned all the Sec2 trigo, all the Sec3 trigos, so let me just recap a bit of what you have learned in Sec2. Sec2, you have learned that if it's a right angle triangle, okay, you can use Pythagoras theorem, you can use Tokasu. And then in Sec3, you have learned that if it's just any random triangle, you don't know whether it's right angle, you can use sine rule when it's two sides, two angles, and you can use cosine rule when it's three sides, one angle. And then lastly, you have also learned in primary school that area of triangle, you can use half times base times height. But in Sec3, you also just learned that half AB sine C works as well. Okay, so what happens now is that there are in general 3 different applications of trigo you need to know. The first one is what we call angle of elevation and angle of depression. The second one is what we call bearings. And the third one is what we call 3D objects. Okay, so I will focus on angle of elevation and depression first. Okay, so what is angle of elevation? What is angle of depression? Now, without looking at the definition, let me just explain to you the motivation behind this first. Okay, so imagine now there is a wall in front of you, and what happens is that you are standing here. Okay, so what happens is that you want to look up to the top of the wall, point B over here. Okay, now then when you look up, right, you realize that you need to tilt your head upwards. Okay, so angle of elevation is attempting to measure how much you tilt your head upwards just to look at the top. Angle of depression, on the other hand, is how much you tilt your head downwards to look below. So for example, to look at the bottom of the wall. Okay, now regardless of whether it's angle of elevation or depression, how much you tilt up, how much you tilt down, you need a starting point first, or the starting position of where your head is. So what happens is that your head, or rather you must always look directly in front of you first. And then you tilt your head upwards. The amount that you tilt your head up is what we call angle of elevation. So you look straight ahead of you, then how much you tilt your head up, that's angle of elevation. Okay, on the other hand, angle of depression, right, is when you look straight ahead in front of you and how much you tilt your head downwards to look at the bottom. So this angle over here is the angle of depression. Okay, now, before I say anything else, I want to emphasize certain things first. Okay, this is extremely important if it's 3D diagram. Okay, but for now, let me just emphasize certain things first. Now, imagine you are somewhere on a parade square in school, and then there is a flagpole. Okay, and you want to look at the top of the flagpole and you want to measure the angle of elevation. Okay, now when you want to measure the angle of elevation from where you are standing, right, you must look directly in front of you, but to the bottom of where you are trying to look at. Okay, so imagine you look directly in front of you. This height here represents your height lah, because it's far away, that's why it looks shorter. Okay, but you must look directly in front of you, underneath the top of where you are looking at first. And how much you tilt your head upwards. Okay, try to visualize that this is the angle of elevation. You must look directly underneath what you are looking at first, but it's directly in front of you. Okay, and then how much you tilt your head upwards. Notice that here is a right angle. Okay, now this is extremely important because if you just anyhow look straight ahead, then you claim that you look straight ahead, then you tilt your head diagonally upwards to look at the top of the flagpole. This angle over here is not your angle of elevation. Okay, angle of elevation is how much you tilt your head upwards. You don't tilt diagonally upwards. Okay, so you don't measure by just looking at any random point, then you look up. Okay, you must look directly underneath what you're going to look up to. Then you tilt your head upwards. Similarly, the same thing applies for angle of depression. Okay, but I just need to clarify this first. This is wrong, this is correct. Okay, and the next thing I also want to emphasize is angle of elevation of B from A is the same as the angle of depression of A from B. Okay, what am I trying to say? Now imagine here. Imagine now I have a bird here. Okay, you look up towards the bird, that's the angle of elevation. If the bird happens to look down at you, okay, if the bird happens to look down at you, the bird's angle of depression, okay, the bird must look straight ahead in front of it first, then tilt its head downwards. This is the angle of elevation that the bird has of you. This is the angle of elevation you have of the bird. You need to realize that because these two lines are horizontal, they are parallel. So alternate angles will tell you that your angle of elevation to the bird and the bird's angle of depression to you is the same. Is the same. Okay, so three things here. Number one, you need to understand what is angle of elevation and depression, how much you look straight ahead and tilt upwards or downwards. And you must make sure you look directly under or above the thing you're trying to look up or down towards. And then lastly, angle of elevation from you to something and something back to you, the angle of depression is the same. Okay, so I'm going to pause here for a while to give you time to ask me any questions if you have. Okay, so let's look at one question first, for example one, to try to see how you can apply or how trigo is used in a typical angle of elevation or depression question. Okay, now say for example, there's a boy of height 1.6 meters standing at Q, and he sees a bird at B resting on top of a tree. The tree is standing at P. P and Q are on the ground, and the distance between P and Q is 35. Okay, now given that the boy observes the angle of elevation of the bird is 39 degrees, find the height of the tree. So basically, what happens is that you first need to understand, because the question never label for you, where is the angle of elevation. Okay, now so the angle of elevation is 39, so the boy needs to look straight ahead in front of him, but underneath the bird, and then how much he tilt his head upwards to look at the bird. This angle here is 39 degrees. Okay, now I'm going to assume that, the height of the boy is the eye level is the height lah. Okay, now so what happens here is the question wants you to find the height of the tree. The bird is on top of the tree. So the question wants you to find this entire height. Let's call it H meters. Okay, now what other information do you have? You have that the boy's height is 1.6 and he is standing at 35 meters away from the tree. Okay, now if I take whatever that I just outlined and take it out, this is actually the diagram represent the entire situation on the right. Okay, so what happens here is there are quite a bunch of information that you need to work out, but the important thing is you must realize that this one here is a right angle. Okay, because you look straight ahead underneath the tree, and the tree is assumed to be standing vertically lah. Okay, so why is this important? Because number one, you know that this is a right angle triangle, and you know that this is 35, he's standing at 35 meters away. So this is also 35. Okay, so using what we have learned in Trigo, okay, you can very easily find this length over here. And when it's a right angle triangle, please don't think of Tuakaso. Please don't think of sine rule or cosine rule. Please think about Tuakaso or Pythagoras theorem. Okay, so this one over here, we use Tuakaso to find. In particular, I want to find this one over here, which I'm going to call it x. Okay, so according to what you know, tangent 39 degrees is opposite over adjacent. So opposite is x, adjacent is 35. Okay, so you can find x by taking 35 times tangent 39. Bring the 35 over. Okay, you should be able to get 28.342 5SF. That's the value of x. And then now all you need to do to find the height of the tree is to take 28.342 plus 1.6, because this length over here is also 1.6. That's the height of the boy. Okay, so when you take your answer plus 1.6, you round off to 3SF because that's your final answer already. So 29.9 meters, that's the height of the tree. Okay, so what I've just done is to show you how to use Trigo in an angle of elevation or depression question. Okay, now the fact that you are always looking straight ahead in front of you before you tilt your head up or down, right, means that when you are trying to solve a question of angle of elevation or depression, right, most of the time is a right angle triangle, and hence you think about Tuakaso. Okay, most of the time is a right angle triangle, so you think about Tuakaso. Don't even think about sine rule and cosine rule. Okay, then let me go through what example 2 with you all. Okay, what example 2, right? What happens is that it's an angle of depression question. Okay, so the first things first, a man stands on top of a lighthouse. Okay, so the lighthouse is actually 72 meters high. Okay, so he's standing on top. He observes a ship at a distance of x meters away. So the ship is x meters away. And the angle of depression of the ship from the man is 18 degrees. Okay, now, what a lot of you will think is that this is a right angle triangle, which you all can all identify. But a lot of you will mistakenly think that this is the 18 degrees, which is wrong. Okay, so angle of depression is not this angle over here. This angle over here is not 18 degrees, and it's also not the angle of depression. Okay, the angle of depression is you look straight ahead, then you tilt your head downwards. Okay, this one over here that you think is 18 degrees, if you think of it this way, right, is you actually look directly downwards, then you tilt your head up to the ship, which doesn't make sense. Okay, the word depression means going down. Okay, so you look straight ahead in front of you, then you tilt your head downwards. Okay, so the angle of depression is you looking, or the man looking straight ahead in front of him first, then he tilts his head downwards. This angle here is 18 degrees. Okay, this is x meters, and this is 72 meters. Okay, so how much he tilts his head downwards is 18 degrees. Okay, so like I mentioned just now, the angle of depression from the man to the ship, right, is 18 degrees. It also is the same as the ship looking upwards towards the man because of alternate angles. Okay, so what you can do is to do the alternate angles, and then you say that tangent 18 degrees is opposite over adjacent. And you find your x by taking 72 divided by tangent 18, and you press your calculator after that. Okay, you will get 222 meters 3SF. So the ship is 222 meters away. An alternative method, right, for this question is to find this angle over here if you want to, because it's 90 minus 18. Okay, that will give you 72 degrees. Then you use tangent 72 equals to x over 72. Also can. Okay, opposite divided by adjacent. It will give you the same answer. Okay, so I hope these two word examples give you a very clear idea of what angle of elevation and angle of depression is.